In this video, we're going to look at the properties of exponents. In our first example, we're going to evaluate 3 to the 5th times 3 to the 2nd. So 3 to the 5th means that we have 3 multiplied by itself 5 times. The power means how many times that number is multiplied. 3 to the 2nd means that we have 3 multiplied by itself 2 times. So altogether here, we have 3 multiplied by itself 7 times. So we can just add the number of times that we are multiplying the base, assuming that the base is the same number. This wouldn't work if these were two different numbers. But since they're both 3's, we can just add the powers. We have 5 3's plus 2 3's gives us a total of 7 3's. Now, a general way that we could write this rule is that if we have b to the n times b to the m, we would add the exponents and put those exponents on that same base b. For number 2, we have 3 to the 5th, and then that's raised to the 2nd power. Notice that this looks different from the first example in that the 2 here is not on a base of 3. What this means is that I have 3 to the 5th squared. So I have 3 to the 5th times 3 to the 5th. Or in other words, I have 2 groups of 3 to the 5th. So we have 1, 3 multiplied by itself 5 times, and then we have another 3 multiplied by itself 5 times. So altogether here, this is our first group of 5, and this is our second group of 5. 2 groups of 5 would be 10, so we have 3 to the 10th. So what happens when we have a power on the outside of parentheses is that is how many times we have what's inside parentheses. And so this means that we have 2 groups of 5. Or in other words, to get the power, we would multiply whatever's on the outside by whatever exponent is on the inside. So in general, if I have b to the n, and it's raised to the m power, this is b to the n times n. Those are multiplied. In number 3, we have 3 to the 5th divided by 3 squared. So 3 to the 5th, again, 3 multiplied 5 times, and 3 squared is 3 multiplied by itself, or 2 3's multiplied together. Now, what we can do in this case is cancel 2 3's from the top and bottom of my fraction here. So those 2 cancel, and those 2 cancel, and that leaves us with 3 3's, or 3 to the 3rd. So, if we have some of the base raised to the power on the top, and some of that same base raised to the power on the bottom of the fraction, we can cancel 1 from each. So however many we have on the bottom will be how many we can take away from the top, or in other words, subtract, and that will give us how many are left. So this is 3 to the 3rd. My general rule for this would be b to the m over b to the n equals b to the m minus n. I can subtract the exponents, again assuming that we have the same base. And my last one here, now I have different bases, but I have the same exponent. So looking at this, 2 to the 3rd times 5 to the 3rd. That's going to be 2 times 2 times 2, and then times 5 times 5 times 5. So what I can do here is group, since I have the same number of 2's as I have of 5's, I can make pairs. So I can make 1 pair, I can make 2 pairs, and I can make 3 pairs. And each pair here is 2 times 5, which is 10. As long as I have the same exponent, it doesn't matter what that exponent is, I would be able to make pairs. So we have 2 times 5. And then since we have 3 of those pairs, that would be raised to the 3rd power. Or that would be 10 to the 3rd power. So to write my general rule here, a to the n times b to the n. Now I have the same powers but different bases. That would be equal to a times b to the n power. Because I can pair each a with a b, multiply them together, and then the exponent tells me how many pairs of those that I will have. So we have 4 general rules here that you can use. And you might remember these rules. You don't need to memorize them. You can always think back to writing out the powers and then thinking about how they will combine.